Well, good morning, everyone, and welcome to the Canadian Northern Corridor Research Program webinar series. Thanks for joining us today. As we begin, I'd like to acknowledge that the University of Calgary is on the traditional territories of the people of Treaty 7 in southern Alberta. The City of Calgary is also home to the Métis Nation of Alberta Region 3. I'm Marcia Nelson, an Executive Fellow at the School of Public Policy, and I'm pleased to be your moderator today. This series is part of the output of the Canadian Northern Corridor Research Program at the School of Public Policy, which is exploring this ambitious concept. And you can find out more about this research program by visiting www.canadiancorridor.ca. We kicked off the series last week with a general overview, and today we're going to dive into the potential impacts of climate change on the project. We'll have lots of time for questions after the presentation, so please feel free to submit your questions as they come to mind by clicking on the Q&A icon at the bottom of your screen. So let's jump right into the presentation. I'd like to welcome Dr. Tristan Pearce, an Associate Professor and Tier 2 Canada Research Chair in the Cumulative Impacts of Environmental Change with the University of Northern British Columbia. And I'd like to welcome Dr. James Ford, who is a professor and Priestley Chair in Climate Adaptation with the Priestley International Center for Climate at the University of Leeds. Welcome to you both, and please go ahead. Over to you, gents.
Wonderful. Thank you, Marcia. Thank you for the kind introduction, Marcia, and thank you for all of those who are joining us online. It's a pleasure to be able to share this exciting paper with you. So to begin with, as we all very much know, building, operating, maintaining infrastructure in Northern Canada is already inherently challenging due to issues of remoteness and climate. And climate change is being experienced in this context, exacerbating existing risks and creating new challenges, as well as opportunities for built infrastructure. So take, for example, to start off with, this image here. When spring flooding in 2017 washed out sections of the Hudson Bay rail line to the port of Churchill, sections of the railway were built over peat bog and permafrost, which at the time of construction appeared to be stable, but is actually highly sensitive to any changes in the climate system. And as such, climate can no longer be considered as a reliable guide in planning future infrastructure. The construction, operation, and maintenance of infrastructure within a proposed northern corridor would have to be undertaken with a clear understanding of expected future climate change impacts. Acknowledging these existing challenges to transportation infrastructure in Northern Canada, our task in this University of Calgary School of Public Policy paper was to review scientific evidence about the potential impacts of climate change in Northern Canada and to examine the implications for future corridor development. To set the context for this work, it's important to understand the scope of the proposed Northern Corridor. The Canadian Northern Corridor would be a network of multimodal rights of way that would span across middle and northern Canada, with an accompanying policy, regulatory, and governance structure. The corridor would provide a space for the coordinated development of infrastructure, such as road, rail, transmission, pipeline, and communication. The corridor would be between 1 and 10 kilometers in width and approximately 7,000 kilometers in length. So we're talking about an absolutely immense footprint across northern Canada that spans from coast to coast to coast. And this footprint would cross numerous ecozones, ranging from Pacific Maritime in the west, to Montane, Southern Arctic, Hudson's Plains, and Atlantic Maritime in the east. So I show this image just to really get across the actual territory that this corridor is working with, and the diverse regions it's going to cross and the ecozones it's going to intersect with. That's important when we start talking about climate, because climate is different depending on the locales. So when we talk about the corridor, we're dealing with a large scale picture, and as a result, when we talk about climate, the impacts are going to be many and varied. The corridor will inevitably interact with the people who live in these areas, many of whom depend on the environment and its resources for their livelihoods. So when we're talking about the implications of climate change for the corridor project, we're not just talking about the environmental implications, but we're talking about the implications for the entire system, which is a linked social and ecological system. In this paper, we draw upon scientific information, but we acknowledge that our understanding of climate change in Canada and in Northern Canada also comes from local and Indigenous peoples' observations and knowledge. And some of these observations and knowledge have been captured in other reports and need to be considered to capture the full implications of climate change for a proposed Northern Corridor. Now, numerous changes in the climate system have already been recorded in Northern Canada, many of which are described in Natural Resource Canada's Changing Climate Report and are synthesized in our paper here. For the purposes of today's presentation, I'll focus on a few of these climate change impacts to give you a sense of how the climate is changing and what this could mean for a proposed Northern Corridor. So to start with, temperature increase. And this image here comes directly from Natural Resource Canada's report. And it's an interesting image because it not only shows the temperature increases generally across Canada, but it really highlights where the most pronounced increase in temperature have occurred and are projected to occur, as indicated by the dark colored amber red. And most of that increase is shown in the northern parts of Canada. And surface area temperatures that are rising have been between 1948, this image, 1948 and 2016, show that the annual average temperature across Canada have increased at about 1.7 degrees. And it is a virtual certainty that this trend will continue based on current atmospheric greenhouse gas and emissions levels. So when we compare the average across Canada with Northern Canada, we see that Northern Canada has experienced an annual average increase of 2.3 degrees Celsius, almost double the rest of Canada, including a 4.3 degrees Celsius increase in the winter. So what does this mean? It means that in the summer, we're experiencing more extreme warm days. Some indications are that we are experiencing more days over plus 30. And in the winter, we're experiencing reduced frost and ice days. Now, this might not seem like much when we're just talking about numbers and small degree changes. But this might be the difference between having a frozen platform on which to build and travel on and not. So for all of us that are familiar with northern environments, it's a huge difference when we have 0 degrees and +1. And this has huge implications for any infrastructure being developed as well as maintained within a corridor project. The proposed corridor would intersect with 6 ports, 4 of which are exposed to sea ice. Now, sea ice extent in the Arctic and Atlantic Canada and multi-year ice in the Arctic have both decreased at an accelerating rate, as demonstrated here in figure 3, with that steep decline in sea ice extent, and particularly an accelerated decline beginning around 2008. Now, multi-year ice, that is ice that has survived at least 1 melt season, is becoming more mobile and is being replaced by seasonal first-year ice, the new ice growth of a single season. Now, these changes can be extremely problematic as multi-year ice has started to drift from the central Arctic Ocean into the Canadian archipelago and from the Canadian archipelago into the Maritimes, creating significant shipping hazards. These changes are also extending the shipping season in the Arctic Ocean and opening up new routes. What we've seen is that ship traffic has nearly tripled in the Canadian Arctic over the last decade. Under high emission scenarios or business as usual models, there's a projected 50% probability that extensive areas could be ice-free, that is 5% ice cover or less, at the end of the summer of 2050. So from what we see on the data for sea ice is that while there's opportunities with the opening of new travel routes and potential for transportation in areas that previously were untravelable, we also see the potential for new risks as that sea ice dynamics changes and presents new risks to the shipping movement. The proposed corridor would cross several permafrost zones across northern Canada, all of which have been affected by temperature increases, which has led to increases in the thickness of the active layer during the summer season and the thawing of ground ice. An example of permafrost thaw are the scars left in the Caribou Hills near Inuvik after heavy rains triggered landslides in September of 2017. Now, climate models using a business as usual scenario applied across the Arctic identifies northern Canada as a region projected to be particularly affected, with infrastructure lifestyle replacement costs increasing by approximately 33% by the mid-century due to climate impacts, putting roughly 20% of infrastructure in these northern regions at risk. So we move that into dollar terms, it is estimated that this will translate to an increased cost that will exceed $4 billion to deal with the infrastructure that's already being affected by climate change, in many instances, primarily by permafrost thaw. So we're talking about airports and runways and tank yards and buildings, and municipal buildings and private buildings and road infrastructure. All the things that make society work is all built upon this very unstable surface. Across northern Canada, we've also been seeing shifts in the distribution of species. And this has been documented as a result or exacerbated by climate change. So there's a potential for the increased northern movement of several species and associated human harvesting activity. The proposed corridor route may not be a primary habitat for species today, but it could be in the future. The proposed corridor and infrastructure built within it could potentially affect or hinder species movement, essentially acting as a border or a wall preventing movement north to south or east to west, particularly in this case, say in the subarctic. And I show this image here because we've witnessed extreme declines and changes in some caribou populations in Canada, and we've seen them moving into areas that they previously were not occupying. So this just raises this question: as the ecosystem changes, so must people. And when we talk about a corridor, where we propose this corridor and how infrastructure is constructed has to be mindful that it's working within a very dynamic environment that has to be adaptive to these changes. I'm going to stay on this slide just for a second because I want to bring up actually one more point when it comes to ecosystems and some of the events that we're seeing. Something that's very important for the corridor is the increased occurrence of extreme events. So climate change can influence the probability and intensity of extreme events. These are things such as forest fires and floods, droughts, and ice storms. And changing temperature, precipitation, and wind patterns have increased the likelihood and severity of these, with the largest changes being experienced in the prairies and northern Canada. So this increased fire and drought risk contributed to extreme wildfire conditions, such as those that we experienced in Fort McMurray wildfires in 2016, as well as the severe ice storms experienced in Quebec in 2018. So the weather is becoming more unpredictable, and with unpredictability, we're seeing extremes. These extremes have implications for infrastructure. When we look at these documented and projected future climate change impacts and ask, what does this mean for the Canadian Northern Corridor? They can be grouped into, in our case, we've grouped them into these categories of construction, operation, and I want to touch today as well on politics. And generally what we're speaking about is that climate change adds another layer of challenges to an already challenging project. When talking about the construction of infrastructure within the corridor, climate change impacts are likely to affect that construction in terms of regulation and design, route planning, and potential impacts during construction. Ensuring that development within a corridor follows a set of codes and standards that are adapted to current and future climate conditions, as well as being adaptable to unexpected change, will be critical. An example of this, when planning the corridor route, considerations will need to be made to avoid areas that are highly susceptible to climate change impacts and those with human occupancy. Now, this image is taken from the Arctic Corridors and Northern Voices project. And this project worked with communities across the Northern Canada to identify preferred corridors for shipping traffic. So in doing so, they're able to work with that current system to identify suitable areas where they can have the movement of goods and not or lessen the impact on the human activities in that area. Climate change impacts could accelerate the deterioration of, and in some instances could severely damage, corridor infrastructure, as per some of the examples given previously. Extreme events like forest fires, ice storms, permafrost slumping, and floods that are influenced by climate change could threaten infrastructure in a corridor and potentially create what we're terming a choke point. Given the remoteness of Northern Canada and the absence of alternative modes of transportation, potential choke points could effectively shut down operations within a corridor. For example, the Port of Churchill, Manitoba is the only deep water port on Canada's northern coast, the only deep water port currently in the proposed corridor area, making it a strategic port location. The port is expected to experience increased potential for growth as the open water season increases with sea ice loss. But use and maintenance problems on the rail bed that supplies the port due to permafrost thaw, as we mentioned previously, could create a choke point for goods to be transported to the port for export. So we can look across the corridor and identify different choke points, and we can see that these potential choke points today are only going to be exacerbated under a future climate. In terms of politics, politics is another consideration when it comes to climate change in Canada, namely Canada's commitment to achieving greenhouse gas emission reductions set out in the Paris Agreement. We need to ask how the development of the corridor, as well as the goods and services that are going to be transported through it, how these may or may not fit in with these commitments. Taking this together, we can draw some key messages or conclusions from this report. The first is that climate change is already impacting Northern Canada and infrastructure in the region. So this includes infrastructure that is similar to what would exist in the proposed Northern Corridor, or other infrastructure that is part of industries that drives demand for expanded transportation through the corridor. Based on future climate change projections, current impacts are expected to continue and intensify into the future. This means that existing and new infrastructure in Northern Canada will be at greater risk of damage. Climate change impacts are likely to affect the construction of transportation infrastructure in the corridor. Now, future climate change projections must be integrated into regulations, codes, and standards, design, and planning routes in order to create infrastructure that's robust to deal with the future climate. And maintenance of infrastructure in the corridor would need to be more robust to mitigate expected climate change impacts. Climate change could adversely impact and even halt the continuous operations of the corridor, as we've just described, with the potential for choke points. And the corridor will need to be responsive to the political economy of climate change. And as we described, this includes the global movement to reduce greenhouse gas emissions and the implications for the infrastructure and the goods that could flow through the corridor. And finally, local communities and Indigenous peoples must be meaningfully consulted early and often in conversations about the proposed Northern Corridor. And this is necessary to identify, A, if a corridor is desirable and relevant, and how it might be impacted by climate change, including how a corridor could exacerbate impacts that are already being experienced by people in these locales. This points to some strategic future research needs. The first is that we need to identify how the proposed corridor could affect existing land use practices and the cumulative impacts of climate change and corridor development for communities. Second, the economic viability of the corridor needs to be studied in the context of climate change impacts, greenhouse gas emission reduction commitments, and changes in global market demands for resources that would be transported in the corridor. This includes estimating construction, operation, and maintenance costs for the corridor under future climate change conditions, and the potential costs that climate change politics could also have on corridor development. And improved downscaled models of climate change impacts along the proposed corridor route are needed to understand the potential severity of change for individual areas. This would allow for an analysis of potential climate change impacts, specifically for particular types of infrastructure along the corridor route, and provide insights into planning for that infrastructure. At this time, I'd like to extend a thank you to the School of Public Policy at the University of Calgary, and specifically Dr. Kent Fellows and Dr. Jennifer Winters for inviting us to lead this important initiative. My co-author, Dr. James Ford, and I will now be pleased to take questions.
Great, thank you so much, Tristan. That was a great presentation. And I particularly liked your starting photo of the rail line into Churchill, because I think it is just so perfectly illustrative of some of the challenges of northern infrastructure projects and really what we're talking about here. Let me start with a question from the audience. It's a bit of a technical question, so hopefully it's not too specific, but the question is the Northern Corridor, as we're currently thinking about it, defined to exclude any consideration of maritime routes comprising the Northwest Passage?
Tristan, I mean, in terms of our analysis, it's mostly focused upon the land-based components of the corridor, but obviously acknowledging that those maritime routes are extremely important for the corridor's operation, especially for shipping. We're talking about the ports on the Arctic, on the Beaufort Sea. Obviously, that's one of the major climate links is through that shipping. Whether that shipping is possible due to sea ice extent, sea ice depth, sea ice coverage, and so forth. So certainly in our report, we do consider that, while the focus is mostly on the land-based components to it.
Great. Another question related to the sea ice cover, I think, with respect to figure 3, the sea ice cover looked like it was for September. And the question from the audience was, is there one for March? You know, and would there be a difference?
Yeah, so I just sent, I just answered in the chat function. I sent a figure there from NASA on that for February, not March. I couldn't quite find March.
Okay.
But yeah, I mean, the trend would be quite similar in that we are across the Arctic. We're seeing later ice freeze up, and we're seeing earlier breakup as well in March. Well, it depends where you are in the Arctic. It's March. It could be. It's the further north you go, it's actually later. It's more like maybe May, June. Again, varying where you are in the Arctic. But there's a very consistent trend that we see here when we look at this satellite ice data, and that is the ice is breaking up earlier in the year. Not quite as pronounced as the later freeze up, but nevertheless, we do see this trend of decline over time. You'll see from the graphs I sent and the graphs that Tristan showed, is actually a lot of interannual variability. So there's this long-term downward trend, which is quite discernible, but there is interannual variability, and that's one of the factors that does make planning quite difficult, because you may get one year where the ice is totally free in October. Another year, you may have actually have ice there. So there's that interannual variability, which makes planning quite difficult.
Indeed. In the paper, you make specific reference to how important it is to engage relevant local communities and Indigenous peoples early on in all the corridor discussions to identify if a corridor is really desirable and relevant and workable from their community perspective. And we have a question that asks, are there examples of best practices that we know of in integrating or reconciling traditional local knowledge with the scientific analysis that you've been providing in the context of climate change effects?
I could start there, and then maybe just you come in, because this is an area that both myself and Tristan have worked on now for about 20 years. I used to be based in Canada at McGill until I moved back to the UK recently, but we've been doing this work for a long time, and we've learned a lot over this time. So there's now quite a lot of work, especially with Inuit communities, basically documenting the effects that climate change is having, documenting their observations, their stories, and also like how those changes are interacting with people's livelihoods and well-being. And I think what really underpins this work, and for it to work well, is the process of how you work with communities. Very much about relationships. So you don't just go there, ask people questions and leave, or go in there with a survey and ask people what they think. You've got to go in there, spend time, multiple years. We've been working in the same communities for about 10, 15 years, really. And it's those relationships that allow people to share their stories of how the environment is changing, of how it's affecting people. So you're co-producing that knowledge. Communities also want to know the science as well. They've got their own traditional knowledge, which they've developed through a very, very close and in-depth interaction with the environment that's been built up over the generations. But communities also want to know what the scientists are observing as well. What do the satellites show us? What does some of the weather station data show us? So having that kind of, we call it two-eyed seeing, the ability to kind of, on the one hand, see what communities are saying, but on the other hand, also look at what the science is saying. You combine them together, you'll get a much more detailed picture of what's going on. Tristan.
Yeah, no, I think just to build on that is exactly that. When we're looking at climate change impacts across this, this huge area, what we find is that the climate modeling isn't actually that accurate when we go into this, what we call a downscaled model. So in a lot of work across Canada, we actually look to people who are living in those specific places. And as James has already said, looking to other ways of knowing and understanding our relationship with the environment to understand those impacts. So what does that mean for the corridor? It really means that for each part of that network, each part of that system, it makes sense to engage with the people, not only in the sense of consultation, but to engage as equal partners in understanding what those changes could be. Because really from the broader climate science, we don't really know. But when we start to combine that with that local knowledge and understanding, we can build a more comprehensive understanding of what those implications are and could be in the future.
I just want to build on that point that Tristan raises, and that is, for a lot of Northern Canada, where the transport corridor is going to go, we don't have weather stations in place. We've got this broad understanding of what's going on at a very, very general scale. But we do have a lot of gaps there in the science about how things are actually changing in specific locations where the corridor is going to go. I think that's one area where communities, they've got a lot of in-depth knowledge. These are often communities, they're small, they're remote. They often have strong links to traditional hunting, fishing, trapping. And so people know the landscape very, very well, and they know when it's changing and how it's changing. And so, again, I think a lot of scientists are increasingly turning to these communities to say, what's going on in these, actually on the ground in these very specific locations.
Well, maybe not a fair question to you folks, but certainly one of the audience members is asking, is there not also an imperative to do broader consultations even in the South? Because those many sort of taxpayers and environmental interests and citizen interests would also be interested in being effectively and meaningfully consulted. So in as much as we need to consult extensively across the North, is there not a need to consult in the South?
Yeah, look, I think, James, I'll start and then let you expand on it. I think with doing this work, it's, of course, we're looking at, we focused on the implications of climate change specifically for the corridor. And we understand that there's another project that's looking specifically at this idea of consultation. So we didn't explicitly go into that area, but it's just obvious whenever we talk about the corridor and we talk about impacts, that consultation is a necessity. And I agree with the comment from the audience that broader consultation, not only from those that are directly impacted by the corridor, but those that have a vested interest in the development of it in Southern Canada and elsewhere, in terms of the goods that are being moved through it, should probably be consulted in that process. One of the things that I'll just to emphasize, the reason we're highlighting this idea of consultation along the corridor route is in the work that James, myself, and many others have been doing is identifying how these communities are already being impacted by climate change. So staying within the theme of the paper, these communities are already dealing with climate change impacts. So when we're talking about future implications, this is something that's a little bit abstract because people are already doing it on a daily basis. And I think in the sense of consultation, when we talk about climate change impacts on the corridor, it just makes sense to understand what's already happening as a little bit of a window to what could happen in the future. James, I'll pass it to you.
Yeah, and just to build up on this idea of consultation, I totally agree, Justin, with what you said. And certainly in the northern context, one of the reasons why we often stress this is because historically, people look to the north and they think it's this massive open space. It is this, Northern Canada is a huge space, very low population density. But there are people who live there. The indigenous communities have lived there for thousands of years, and people's traditional territories are often very, very extensive and often widely used as well for traditional activities. And so I think the duty of consultation really, requires communities to be engaged because of that. And historically, communities haven't been engaged. It's changed in recent years, I know, but historically, developments happened in the north which communities were not involved at all with. So that's one of the reasons why in both Justin and all of our work, we continually emphasize this importance of consultation. But it's important in the south just as much as it's in the north as well.
Well, James, to pick up your point on population, did your study, or are you aware of any studies that gathered some additional data on forecasts of increased population over the next 50 years in the area where the Northern Corridor is being considered?
That's a good point. In our research, we didn't look into that, but I think it's certainly obviously it's an important area. There's a lot of factors will affect that. Obviously resource development trends will have a big role. Certainly, a lot of the communities along the Arctic coastline, so the Inuit communities, we're seeing quite large increases in population, both through growth within the communities themselves and also immigration from southern Canada as well to some of these communities. It does vary by region, very by community though. But certainly, I think, yeah, when you're looking at the corridor, looking at some of those population trends, I think would be worthwhile doing.
Right. Another question really goes to the impact of climate change, and is it a net positive or a net negative? So when it's very easy when you look at some of the climate impacts you're talking about, very significant implications for existing infrastructure like ice roads and as we've already talked about, ports and so on, and existing infrastructure. So we expect that a new major infrastructure project would be subject to the same kinds of considerations. So do we think this is a net negative or a net positive for the business case to move forward with this kind of a project?
It's a pretty tough question. It's a question we often get asked in our line of work, and it's difficult to answer because at the end of the day, to some extent, it's going to vary depending upon who you are, what your livelihood is, where your community is located. It's going to differ at very many different scales. Even in communities that we work in, there's people benefiting from climate change impacts. There's people losing out. So making that kind of high level statement about how it's going to play out at a net level, it's very, very hard to do, and it takes a lot of generalizations, shall we say. Basically, what we do in our work is we try and look at both the positives and the negatives that climate change might bring, and that's what we did in this study. And there's certainly benefits to be had from developments like this. There's negative impacts. How they play out at a net level, it's very hard to say. I'm not sure, Tristan, if you got some better insights here than me.
Well, and look, the area that the proposed corridor would cross is so expansive that I think it's difficult, if not impossible, to describe net benefits or net losses. In some areas, what we've seen is that, of course, with sea ice, that new shipping routes have increased, and as a result, from the perspective of companies that have their vested interest in moving goods, this would be a good thing. And in some areas, they're able to work together with communities, as we see off the coast of Nanette-Siavit off northern Labrador, where shipping traffic and community interests, they're seeking a balance. But in other areas, these are unknowns. In other areas where we see that permafrost thaw is happening at accelerated rates, I don't think it's necessarily a question if this is going to be a challenge. It is going to be a challenge, if not impossible, to build infrastructure on it. We're already seeing challenges to infrastructure due to things like the choke points. I think extreme weather is one that, again, it's unpredictability. So even if we did make a judgment on the benefits. You could have an extreme weather event, which would essentially stop or put a choke point on that corridor, making it essentially ineffective. So I think it's impossible to answer it, but it's one to consider at individual infrastructure project levels.
I mean, I think it's the kind of question too that requires an approach, basically developing different scenarios. Again, there's not going to be one right answer, but you can potentially bound some of these potential futures by looking at different scenarios of how things might play out in different regions over different timescales. And this is what we do in the climate change context. We try and understand the future, what things are going to be like in 50 years' time, 100 years' time. It's obviously that there's huge uncertainties here, and those uncertainties we often can't get around, just the nature of how the future works. But we can try and bound them by using a variety of scenario-based planning approaches. And so, certainly, if the project was to look into that, you may get some high-level bounding of what those net overall impacts might be. But basically, the spread of potential impacts from a high scenario to a low scenario. So that'd be one way to start thinking about really exploring that kind of question.
Well, I just have to ask you what I am thinking of as a Rumsfeldian question that one of our audience members put forward in the kind of the language of Donald Rumsfeld, and that is, when we think about these extreme weather events, and we've just talked about scenario development, would you consider this a known unknown? In that these events are known and have known effects, and they are predictable, and there's some increasing frequency around that? Or, are we talking about unknown unknowns, right? Things that we, don't know about what their effects are, and we don't really understand their anticipated frequency. So where are you on that tongue twister of a continuum?
There's always unknown unknowns. We're never going to know them because by their very nature they're unknown unknowns. So yeah, for sure. There's one of things happen that that are outside of our current understanding of what's possible. That always happens. But I think a lot of the risks they are known unknowns in a sense that we know that while there's a lot of uncertainty, there are things that we do know. We know that all the models are showing us things in the north, they're going to warm. Not a single model shows cooling. We know that permafrost is going to decline. Not a single model shows permafrost expanding. We know precipitation is going to change. Not a single model shows it staying the same. So we know those kind of general level insights of how things are going to change at a very, very general level. But it's when you start asking questions as about when, how fast, and how they play out in specific locations, around the extremes, for example. We know there's going to be more extremes. That's what basic science says. We know that. When those extremes happen, their distribution in time, how severe they are, those kind of things is where the unknowns really, really lie. And however much science we do, there's a limit to how much we can know. It's like weather forecasting, right? It's just, we can forecast 5-6 days in advance relatively easily. Forecasting 2 or 3 weeks is very, very difficult to do. There's basic levels of scientific uncertainty which we can't get past. It's the same here. So it's a lot of it is a case of known unknowns in many cases, but I'm sure there will be unknown unknowns which we don't know.
Great. Well, let me ask a couple of questions about permafrost. One audience member is interested in whether the Canadian permafrost science and engineering community that's already engaged in this research, how involved are they in some of these analysis so far to date, or is that a source that you've gone to in your work?
Yeah, I mean, certainly Canada has a very well developed permafrost research community. There's a lot of excellent research going on across the nation. Very much from a natural sciences perspective, although increasingly also engaging with communities as well to assess the risk posed by permafrost thaw. There are efforts again across the north to provide communities with permafrost maps to help them plan their infrastructure and their developments. So there is good stuff going on, and in our work in this project we kind of summarize some of that research and relate it to the corridor and what that research is telling us for this proposed development. And as well the work outside of this project, I know in my own research in Nunavut, for example, we've looked at how communities use permafrost maps and how they've been involved in permafrost mapping activities. So looking at it more from a kind of decision support tool. And Tristan, have you been involved in permafrost work?
Yeah, look, no, I think you captured that well, and I take the point from the the audience that there's a lot of work on permafrost, and I think James captured it well. A lot of it's coming from biophysical science. We have a lot of modeling on permafrost, and in this report, that's exactly what we did. Was we took a synthesis of the most relevant and most up-to-date science and included it. But I think, James, what you said earlier is something to take note of, which is, all models show that permafrost is declining. It's not expanding. And essentially, the way permafrost is doing that, it differs depending on the type of permafrost in the area, but all of them, in every area, if it's sporadic or discontinuous or continuous permafrost, we see a decline in this permafrost and a thawing across the region.
The impacts will really differ. The impacts will differ a lot depending on where you are, depending upon the nature of the bedrock. So, in parts of Nunavut, for example, you've got communities developed straight onto bedrock. Obviously, the permafrost thaw isn't as much of an issue there. But then you got communities like Tuktoyaktuk in Northwest Territories, which have large amounts of ground ice, which makes it then very, very at risk to ground subsidence. Also, along a lot of the Arctic coastline, you've got the cliff that the kind of coastline is basically held together by the permafrost. It basically holds the soil together. As that permafrost melts, what you see is slumping of the coastline, making it more susceptible to sea level rise and to coastal erosion. So the permafrost thaw, it differs a lot in terms of its speed, but also in terms of its impacts, depending upon where you are. It does vary quite a lot across Canada.
Yes, another audience member notes that the University of Leeds has quite strong links to the Republic of Mongolia, where permafrost is also a major feature. And they wondered if, James, you could share some of the knowledge of that relationship with Leeds and with Mongolia, considering, that both economic and anthropological and climate, considerations.
I wish I could, but this is the first I've heard of it. Leeds, we have a very, very big Earth and Environment department. We have a lot of research going on in both the natural sciences and social sciences. So if the person who made the comment knows someone, I'll be definitely happy of hearing who that person is, because I'd like to find out too. But certainly, there's, in terms of what we can learn from elsewhere, there is a lot that Canada can learn from other countries with permafrost. So there's a lot of work going on in Russia, for example, where Russia is even more susceptible, I think, than Canada is to permafrost thaw. They've got huge amounts of infrastructure built on permafrost. And they've also got very, very old infrastructure, which is very susceptible to permafrost thaw too. And so there's a lot of work coming out of Russia on permafrost modeling. So I think there's definitely things that we can learn there in terms of the risks and how they manage those risks. But as for the Mongolia work, I don't really know.
One of the audience members is interested in the air and transport connections. Certainly, we're a lot of attention being paid to what's happening on the land. Certainly, attention being paid to what's happening in the sea. What about some of the implications for air connections and the impacts on extreme weather that might prove a hazard for air transport?
Yeah, so I mean, historically, there's not been that much work done on air transport and climate change in Arctic Canada. We're starting to see a few studies coming out. I think there's some work coming out basically from Nunavut and from Churchill, Manitoba. And certainly, there's a number of trends of interest here, one of which is changes in levels of visibility due to fog. And, we're talking here a lot of mostly very, very small airports which have minimal kind of infrastructure to allow planes to land in poor visibility. And so some of the analyses that have been done have showed, decrease in the number of suitable flight dates due to changes in visibility. Again, visibility varies a huge amounts across the Arctic, and there's no reason why climate change would necessarily compromise visibility, but in some communities we are seeing a trend of declining visibility. Wind speed is obviously a big issue. Small airports, small planes can't operate in high winds. So that's also a potential issue, because across the north we are seeing changing wind, and could well see more storms, more wind in the future if climate change impacts. So there are uncertainties there. So that would certainly affect air transport, but also permafrost thaw. I know a lot of the big airports, like Iqaluit's runway, is built up partly on permafrost, and we're seeing the runway in places subsiding as we are in Kuujjuaq as well. So there's a number of risks there to air travel, which in many cases are magnified by the nature of the air infrastructure in remote small settlements, which tends to often have gravel runways, often have limited kind of ground-based radar to help planes when landing, but also permafrost thaw as well with its impacts on runways.
Great. Another question relates to a bit of what's new here. And by that, I mean, traditionally, developing infrastructure projects in Canada, are not insignificant challenges. Challenges with weather, challenges with topography, all challenges with remoteness, Indigenous rights, etc. So, the idea that climate change would make that all that much more difficult. I think the audience is questioning, look, we've had challenges developing our infrastructure in remote territories with extreme weather in the past. Do you think that your analysis would suggest that it's materially more difficult to do that now with these climate change effects, or are these simply going to be factored into any kind of resource development that's going to occur in the north?
Yeah, I'll start off. I think I see there's really two layers to it. One is the social license to have these infrastructure projects, and I think the audience members speaking to that there's definitely a need for social license that comes not only from within the corridor region, but also from elsewhere within Canada and globally when it comes to the movement of materials, especially when it comes to fossil fuels. When it comes to the social license and consultation of people within the corridor, I think that's extraordinarily complex. We can look into the history and the recent history of any big infrastructure project, be it the Mackenzie Valley Gas Pipeline project back in the 1970s and 80s in the Beaufort Sea area, which is a similar region to where this corridor is proposing to work. And what we see from that is that it's a lot more complex than just consulting, that we have different people with different needs and different interests and different relationships with the environment and different desires to have a different balance. So one thing to take into consideration is when we only talk in money, that doesn't necessarily translate to the same thing for everybody. More money isn't necessarily what these communities are looking for. They're looking for a balance of some economic prosperity that balances with traditional livelihoods. When it comes to cost, I think from the literature on the cost of climate change and infrastructure development in Northern Canada, what we generally see is things just cost more. It already costs a lot to build and maintain infrastructure in Northern Canada, but you superimpose these climate change risks. And as James has already highlighted, they're going to be varied, and some of them are extreme. But when you take it over a certain time scale, you see it's just more expensive. So I'll pass to James without saying too much more.
Yeah, I mean, I agree with those points, Tristan, fully. I think, when looking at these large infrastructure projects, I mean, there are some issues that are similar to conventional planning for large infrastructure projects. There's a lot that we can learn from how those projects have been developed over the last century, really, I think, in many ways. I think what differs about climate change and planning for climate change impacts is what's been termed the death of stationarity. When we look at how past infrastructure projects have been planned, you expect extremes to happen. You expect floods to occur, wildfires to take place, but you don't expect the permafrost to melt. You don't expect the climate to be changing as rapidly as it is changing in the Arctic, where we see, events that were once 1 in 50 years, now happening 1 in every 4 years. And so I think is what makes it unique is it's the speed of change, and the fact that historically when planning large projects, they plan for extremes, but they don't plan for change in the baseline conditions. And especially in Northern Canada, it's probably going to see the most climate change of anywhere globally this century. You're looking at some of the high scenarios are showing that by 2100, you could see 8 degrees Celsius of warming in the Arctic. That's average temperatures. That's a huge change in climate. It will have huge transformational impacts on how the landscape looks, on hydrology, on ice, on permafrost, on ecology. So I think that's what makes it unique. And if we look across different contexts, whether it's Canada, the United States, Europe, Russia, is when it comes to big infrastructure, having a hard time planning for this. We've known about climate change now for a long time. It's become recognized as a risk for infrastructure for a long time, but we're having a hard time building these projections into our infrastructural projects. So it's not easy. It is complex. I think that's what does make the future now unique compared to what it was in the past.
Thank you for that excellent answer, because I have to admit, when I read the paper, that was the sort of biggest takeaway for me, was just the rate of change and how that makes our ability to plan so much more complicated. That, you know, that one statistic of 1 in 25-year flood events in Tuktoyaktuk going to 1 in 4 years. I mean, that is, you know, from a person who has, you know, spent a career in public service and planning and mitigating these types of events, that was just a stunning fact for me. You talked here about innovation in consultation, right? So we need to do consultation in vastly different ways in order to be able to be engaging and kind of respectful and appropriate methods. Are there innovations or advances in technology that you're aware of? You know, things like, you know, rigid, high compressive strength insulation and refrigeration, things that weren't available when, you know, we built the railroad, you know, 100 years ago. Anything you're aware of that would be really helpful in this kind of corridor development?
I think the good news is that there are often technologies available to help us adapt to some of these changes. And we're seeing huge developments, for instance, around managing ground temperatures to alleviate the impacts of warming on permafrost degradation. Things like thermosiphons, for instance, and other ways of constructing on permafrost which maintain the ground temperature such that you limit the melting, basically. We see that actually in Tibet, in China, when they built the kind of the railway there that went through permafrost in the mountains. They developed a whole range of innovative technologies to maintain the permafrost temperature quite low. So often our technology is there. The problem is it costs a lot of money, especially at the scale we're talking about here. We're talking about a corridor of 7,000 kilometers. It's very difficult to build these climate adapted technologies at that kind of scale. But there are some places where it is going to be too difficult to adapt to. So for instance, in some work that I've been doing with some colleagues across the Arctic, one of our communities was Tuktoyaktuk we were looking at, and we looked at different options to adapt for adapting to sea level rise and coastal erosion. And what we find really is that by the end of the century, there's no adaptations really that can offset the impacts that climate change will have that are cost effective. And that's probably that's an unfortunate conclusion. That's probably going to face quite a few of the most vulnerable communities in the Canadian North, that the very viability might be affected by climate change impacts, even if you adopt the technology that's available there to help manage those changes. But it does vary by the risks that you're looking at, what technology there is there, but cost does remain a big challenge to feasibility in many cases. I'm not sure, Tristan, do you have any more?
Yeah, no, just to build quickly, I take the point with things like the Hudson's Bay Railway to the Port of Churchill, where it's built in early 1900s, and absolutely things have changed, and you know, infrastructure can be planned better and it can be differently and it can be rerouted and whatnot, but I think what it shows is that it costs a lot of money, even to get the Hudson's Bay Railway up and functioning again back a few years ago. You know, millions of dollars in investments, and again, it's still highly sensitive to flood events, which are increasing in frequency. So I think a short answer is absolutely. I think technology is going to play a huge role. And yes, you can mitigate some of the thawing of permafrost, but even thermosiphons have a lifeline. You know, it's 10, 20, whatever years, but eventually they're not going to be able to, as James said, eventually you're going to hit that tipping point. And I think that's the same thing when you talk about rail lines, and you talk about building on any unstable surface. There's always going to be some degree of sensitivity to change. And in order to mitigate that, it's either going to be impossible or cost a lot of money and a lot of maintenance to do.
Now, back to that maintenance.
It's an example too where the kind of complexity comes in around why today is different than in the past, in the sense these technologies exist, but it's what kind of future do you prepare for? Do you prepare for the future of 8 degrees Celsius warming under a high emissions scenario? Do you plan for the middle of the range, 4 degrees Celsius of warming, or do you plan for the lower end of the range? Each of those options will have very, very different costs and very, very different impacts. But you know, who knows what kind of warming we're going to get to in the future? But that's got huge implications for the kinds of investments that we make now. And if we make the wrong investments now, those investments may have a lifespan of 50 years, 100 years. They may have negative impacts as well that we don't know about. So again, this really shows this kind of complexity of planning in light of an uncertain future.
Again, one of the audience members says, so in light of this whole conversation, you know, should we be moving away from land-based types of solutions, and focusing more on kind of air and sea.
I mean, yeah, I know for air-based transportation, a few years ago, there was a lot of talk about using airships for supplying Arctic communities, as offering kind of a relatively cheap, low impact, potentially low carbon option of supplying of transportation in the Arctic. I'm not quite sure whether research on that went. I mean, shipping for sure, but then with shipping, the issue comes in. You've got to have port infrastructure, and again, in looking at in northern Canada, there are investments being made in deep water ports, but there are also challenges of operating in the Arctic as well. Opportunities too. Obviously, changing sea ice conditions potentially create a lot of shipping opportunities in the Arctic, but also bring risks as well around the potential for an oil spill, potential for certain, if a ship gets into difficulties, there's very, very little search and rescue capability at the moment in Canada's northern Arctic waters. So again, even there's a lot of challenges. Basically, there's opportunities and challenges at the same time.
Before we run out of time entirely, I think the one question I have to ask is around your kind of political context and social license. And, I think what we've seen in the past with major infrastructure projects is there's a real concern about how development and implementation of those projects would further GHG emissions in the country, because it facilitates, the transport of fossil fuels in some cases. In this corridor concept, we're also talking about facilitating bandwidth expansion. We're talking about facilitating electricity transmission. So, in your analysis of climate impacts, have you got an answer for us on whether something like this kind of corridor would be a kind of net positive or net negative on GHG emissions?
Yeah, I'll start, James, let you continue. The first is, anytime you talk about the corridor, absolutely there's a diversity of infrastructure that can be put in it. But one of the things is that it is an open corridor, and it's supposed to be streamlining a lot of these regulatory processes. And of course, you're going to have things like bandwidth and whatnot, but it's inevitable that we're going to see fossil fuels at this time going through it, because there's this big push for pipelines, and there's a big push for movement of oil and natural gas and bitumen and whatnot. And I think that's where it comes into, is this question about what future we want to see. And that's a conversation that's already happening in Canada. But when we sign on to something like the Paris Agreement and we're trying to limit our greenhouse gas emissions, we then have to ask, is this the type of energy production and movement that we want to facilitate? And if it's not, then we have to put limitations on what goes to the corridor. And that's a conversation that has to unfold. But I think at this current time, and our reading of the literature, is that political considerations are extremely important for the social licensing for the corridor, but also for the feasibility of the corridor in terms of who's going to be buying these products, if that future changes on what people are demanding, what energy becomes most desirable.
Great.
I don't we have too much to add there, but yeah, I mean, I think there is potential that corridor could be used in a low GHG context, but in the current situation, I think it's unlikely. But you could see a future, but yeah, where there's green development taking place, and where the kind of corridor enables that, be it wind farms, be it hydro. There's a whole range of potential opportunities there, which a corridor could potentially have a low carbon green economy benefits. But it all depends on how the corridor is conceptualized, and what kind of future is really envisaged through it. Yeah.
Great. Okay, final question. And maybe you can just give me a short answer so we've got time to close. What do you see as the single most significant outstanding climate change research issue arising from your analysis thus far? What more work do we have to do?
Well, I can give a really quick one, then I'll pass to James. I think one of the big things, if we're talking about climate change implications and we move it outside of the politics and we just focus on a corridor infrastructure that's going to be within it, I think what we need is targeted downscale modeling of climate change impacts relevant to specific infrastructure. Right now, our modeling is very general. It doesn't necessarily give us too much information on what climate change could do for the specific types of infrastructure, taking into account things as discussed, new technologies, ways of building. James?
Yeah, and building on that, then looking at this idea of choke points. This is one of the kind of concepts we talked about quite a lot in the report, was the fact that what really matters in the northern context is the fact that there's not much diversity in transportation options. So if your rail line goes down, your road goes down, It's not like in the south where you can route it through a different network. In the north, that's not available. So these choke points can play a huge role. And so linking some of those downscale models to understand how those choke points might play out in light of some of the impacts that we're seeing, but also really putting a strong emphasis on community engagement as well, and looking at what some of these climate change impacts might be in the context of the corridor development.
Thank you so much. What a fantastic discussion today, and on this very interesting and complex topic. So thank you both for joining us. I'd also like to thank the audience for tuning in and asking some great questions. I want to remind people that I want them to join us next Thursday, November 26th, for a discussion on financing and funding approaches for the establishment, governance, and regulatory oversight of the Canadian Northern Corridor, another very meaty topic for us to dig into. So thank you, everyone, and have a good afternoon.